Here we are going to review the distributive property. Before I do that, let me discuss some of the tools you will need. The first one is when you're multiplying numbers. If you're multiplying a negative number by another negative number, the outcome is a positive number. If I'm multiplying two positives, well, then that stays positive. If I multiply either a negative by a positive or a positive by a negative, so when the signs are opposites, the answer will always come out negative. Also, we have to use an exponent law that will be useful for multiplication. So there are several different exponent laws. One of those that we will use is this one here. And it says that when you're multiplying two things with the same base, so let's say you have two terms, they both have the same base, and you're multiplying them. Even though it's called multiply, this is what ends up happening. You end up keeping the base and you add the exponents. Let me explain why that makes sense. Let's say you have a to the power of 2 times by a to the power of 3. A to the power of 2 is just a times a. A to the power of 3 is a times a times a. Now, if you look at it, you have a, you have 5 copies of a. And so that's written as a to the power of 5. That's the idea. A to the power of 5 means that you have 5 copies of a. Now, of course, in real life, when we do the math, we're going to skip this step. We're not going to show it. But you can use this example to believe the property that if you have a to the 2, that it means a times a, and then a to the 3 means a times a times a, and when you multiply those all together, you get 5 copies of a, which is written as a to the 5. And so think about it, a2 times a3, 2 plus 3 is 5. That's what the property is trying to tell you, that you can skip this intermediate step, and that the final answer will just simply be the 2 exponents added together. So even though when I speak, or when you speak, you're going to say multiply, but you're not actually multiplying anything. You're adding the exponents and you're keeping the bases the same. So let's go through a few examples. I'm going to do the first one. I would highly recommend after I do the first, you pause the video to try the second one on your own, and then you can play it, see if you get the right answer. Okay, I want to do the math here. Now the question will typically say, expand and simplify. So expand means you're going to multiply it together, and then simplify, you're going to make it look as nice as possible. Let's begin. I'm going to multiply 3x to the 4 first with 2x to the 3. 2 times 3 is 6. So that takes care of the coefficients. 2 and 3 form a 6. They are multiplied there. But then I have x to the 4 multiplied by x to the 3. Again, I call it multiply. It's called multiply, but it's actually simply adding your exponents. X to the 2, x to the 4 times x to the 3 is x to the 7. So now, pause the video. You try multiplying 3x to the 4 with negative 6x squared. Try that and then play the video. 3 times negative 6. It's a positive number times a negative. That gives you negative 18. X to the 4 times x to the 2. Again, it's called multiply, but it's adding the exponents, x to the 6. Then the last one. 3x to the 4 times 3x. If you don't see an exponent on your variable, it's because it's a 1. 3 times positive 3, that's just going to be a 9. So you have a 9 there. X to the 4 times x to the 1, add the exponents, you get x to the 5. Right? So again, pause the video, try the second example on your own, and then play it, see if you get the right answer. Okay, so over here, let's do this one. Right, multiply first. Negative 2 times 4 is negative 8. Y to the 5 times y. There's no exponent on y. It's assumed it's 1. Y to the 5 times y to the 1 is y to the 6. Then let's continue next. -2 times -6, positive 12. Y to the 5 times y to the 2, y to the 7. Right? So you're figuring out what the new coefficient should be. -2 times -6 is 12. And also what the new exponent should be on the y. Y5 times y2 is y to the 7. Then the last one. -2y to the 5 times 8. -2 times 8 is -16. But then the only exponent on y that we see with this multiplication is just y to the 5. Right? There's no more y exponent. It's just y to the 5. There's nothing to be added. It also doesn't go down. I see this mistake all the time. Students remove the exponent or they remove the y. It's like, no, you can't do either one of those. You still have y to the 5 as part of that multiplication. These two terms, when multiplied together, they are going to have y to the 5 with a -16 in front. Okay, one more. This one is a little bit more complicated, but you can copy it down and try to follow along. So let's multiply. I want to multiply these together first. -5 times -3 gives me 15. A times A. Again, there's no exponent. It's an invisible 1. A to the 1 times A to the 1. That gives us A to the 2. B to the 2 times B to the 4 gives us B to the 6. Then again, continue. Multiply once more. -5 times +2 gives you -10. A to the 1 times A to the 2 is A to the 3. B to the 2 times B to the 1 is B to the 3. Right? No exponent on this B. It's assumed it's a 1. And then multiply these together. -5 times -4. When you multiply two negatives, you get a positive. 20. A to the 1 times A to the 3. That's going to be A to the 4. And then again, there is a B in the answer. Look at it. When you multiply these together, there's still a B. You can see B to the 2 in there. But it just doesn't change any further. Just B to the 2. But the A's, A3 and A may become A to the 4.